Today we're going to be looking at triangle congruences. What makes a congruent triangle? What is a congruence? Well, in order to have a congruence, it has to have the same shape and size. Items are not congruent if they are not the same shape and same size. Our congruent symbol looks like this, an equal sign with a tilde on top. In order to have congruent triangles, our congruent triangles have to have, there are triangles with the exact same shape and size, like the examples we have right here at the right. Congruent triangles. So congruent shapes, in order to have a congruence, they have to have the same shape and size, and we use this symbol right here to identify that. In order to have triangles that are congruent, they have to be like that example there. Well, there's ways to prove these things. Okay? So we can take and do these by all of these items over here on the right. We have SSS, SAS, ASA, AAS, HL. Notice there is not any of these right here. So SSS means side, side, side. All three sides are congruent. If all three sides are congruent of the triangle compared to another triangle, then the two triangles are congruent. We have SAS, which that one is side, angle, side. For these, notice that the angle is included between two congruent sides. If this is true, then the two triangles are congruent. We also have ASA, which stands for angle, side, angle. And with these, notice that this time our side is included between the two angles. This also shows that two triangles are congruent to each other. Another one we have is angle, angle side, AAS, angle, angle, side. Here, we have to pay attention to the orientation, that the angles match up this way, and then the side that is here has to be congruent in that order. Angle, angle, then the side. And those create congruent triangles. And our last one that we have down here deals with right triangles, and it is the HL, or hypotenuse, leg. So if we have a leg and a hypotenuse that are together, then those two are congruent. Now the corresponding sides of triangles are the sides that are the same position on the shapes. So they have to be in the same position on the shapes. And there are examples of these here to the right. And corresponding angles are the angles that are in the same position on the shapes. So looking at the example on the right here, notice A and R go together. Notice where they're located when we write our triangles here. Notice that AB goes with RS. Notice how they are also oriented with the way the triangles are written. We can use all these information here to help us go and do proofs to prove that triangles are congruent. We have a couple examples we're going to go through and do together. Our first one here gives us a triangle here. Where my given information is that BD bisects AC and AB is congruent to BC. Anytime we have information like this, I always like to go and mark on my triangles exactly what has been given to me. So I have here that BD bisects AC. So I know that this piece and this piece are going to be congruent, and we will get to that later in the proof. And then it tells me here that AB and BC are congruent. That was given, so I have these pieces here go together. Now, like always, the first line of my proof I start with is my given. So I have my given written right here. So right here, my reason, number one, given. Here is where I'm going to go through and state that, AD and DC and CD are congruent to each other. That one would be my definition of a bisector. We're going to have to pull back and remember a lot of the things that we've been doing all along with our geometry. Next I have this middle line right here. This piece right here says BD is congruent to BD. Well, that would be our reflexive property, saying something is congruent to itself, our reflexive property. So we now know that our two triangles are congruent to each other by side, side, side. And if our triangles are congruent to each other, then we have just proven that C is congruent to A because corresponding parts of corresponding triangles are congruent, or CP, CTC. Looking at another example we have here, and this one right here, it says given, the BD is the median of AC to AC, and AB is congruent to BC. So we have here, these pieces were given to us, AB and BC. This one is congruent to this piece. So, and then it also tells us, a median. Well, if we can't remember median, we'll come back to that in a second. So the first thing here, this piece, number one, is given. Number two, that was another given. This one right here says AD is, you're right, medians. Medians also are like a bisector where it chops these pieces in half here. So these two pieces are congruent to each other. This is our definition of a median. Next we have, again, our reflexive property. These two pieces are congruent to each other. So moving along with this reflexive property, so number 4, we write reflexive, saying one piece is congruent to itself, reflexive property. Our triangles, again, just like the last example, are congruent to each other by our side, side, side. And therefore our last one right here, these two angles, angle CBD is congruent to angle ABD because corresponding parts of congruent triangles are congruent. CPCTC. Proofs. Proofs are roadmaps of going from point A to point B with all the details in between. Pay attention to what you're doing. Use all the information you've been given, plus what you have learned throughout the year or working through geometry.